Integrated Sciences, Mr. B, and we're going to continue on with our exploring the solar system. The last video kind of focused on more of our ancient views of the solar system, whereas now this one's going to talk about a little bit more of current explorations that are going on, kind of some of the more up-to-date information that we know to be true about our solar system. So for our first one here, if we can go to the next slide, there we go, is what bodies make up the solar system. So our solar system, it consists of the sun, the planets, the moons associated with the planets, and a variety of smaller objects that mostly revolve in the same plane around the sun, again in our heliocentric model with the sun being at the center. So the ancients knew of 6 planets, again, Earth, and then Venus, Venus, Mercury, Mars, Saturn, Jupiter, and I think, I can't remember if I said them all, but they're all in the last video. And then once we had the help of our good friend the telescope there, we were able to discover Uranus in 1781, Neptune in 1846, and then our good old friend Pluto in 1930, which Pluto has been later classified and reclassified as a dwarf planet, which I think current state is in fact still a dwarf planet, but again, that can be something we take a look at also in class as well. So again, giving us a grand total of 9 planets within our solar system there. Except for the 2 of Mercury and Venus, all the planets have moons around them. Again, we call our moon the moon, but just what a moon is, it's a relatively small natural body in space that revolves around a planet. So just like we revolve around the sun, we have smaller objects that, again, natural objects there that revolve around a planet as well. So we call ours the moon, but we have names for all the different moons of the different planets, which again, I think when we get going on later on, we'll talk more about those. The sun, again, just to kind of talk about some main parts of our solar system, the sun being at the center is very important. It's about 750 times greater than the mass of the rest of the solar system combined. So that's a big kind of important piece of information there. The sun is just gigantic compared to everything else. Again, combine everything in the solar system, sun is still 750 times greater than the mass of all of that. Again, and unlike the sun, planets and moons don't produce their own light, so all light that we see comes from the sun. Again, the reason why the moon looked so bright and lit up is just reflecting light from the sun. The nearby planets and moons are visible because sunlight is reflected from their surfaces, which I just said there. So again, when you see a bright shining object in the sky, again, we can see Mars sometimes in our night sky, we can see Venus, we can see Saturn. The reason why we see those is because light is being reflected from the surface of the sun. Again, they do not generate light on their own. Again, it all comes from the sun. And the planets orbit mostly in the same plane, though they do not line up as shown here, so there will never really be a time where all the planets align, again, when crazy things happen. That's what people say there. But here's, again, all of our planets. Again, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and our good old friend Pluto right out here. Oh, wrong way. So again, this is just kind of showing relative distance that everything is from the sun. Again, this is not saying that, yes, at one point in time all the planets will be aligned. Again, pets might start going crazy and all kinds of crazy things might start happening if all the planets lined up like that. But this is just to kind of give us an idea of the distance of how far everything is. Again, the distance being an astronomical unit, which we'll talk about here right now. Distances between objects in the solar system, again, they're much larger than the distances on Earth. We can't just say that, again, miles and feet or meters, again, if we want to be correct there with our kilometers. The astronomers often use what's called an astronomical unit to describe distances within the solar system, and they abbreviate that as an AU. And an AU comes from the average distance from Earth to the sun, which again kind of just says how we think so highly of ourselves there. So to give you an idea, we are 149,598,000 kilometers from the sun, and so that is classified as just one astronomical unit. As you can see, that is probably going to be much easier to work with than if working with our SI units of kilometers there. So again, that'd probably be something important you need to write down there, what an astronomical unit is, and the fact that it equals the average distance from Earth to the sun. So that's just kind of background of what our solar system kind of is composed of. So how are we exploring that solar system? Because that's just another kind of hot button issue of whether or not we should even be spending the money to explore space. Again, there's obviously a lot of people think that that is something important. Again, I think it probably should be important too. Again, we have complex telescopes, we have piloted spacecraft, we have space probes, and again, it's allowed scientists to explore the solar system. So I'd maybe jot down a couple of these modern pieces of technology, again, probably all three of them, the complex telescopes, piloted spacecraft, and the space probes as well, because those are all things that allow us to explore our solar system. The first rockets were developed in the 40s and the 50s to enter outer space, to actually leave the Earth's atmosphere. So that was one of our first kind of actually getting out there and exploring the solar system, occurred in the 40s and the 50s. Again, then the quest to reach the moon, again starting in the 40s and the 50s, and then there's a big space race going on to see which country would be the first one to reach the moon. And on July 20th, 1969, Neil Armstrong, which was commander of Apollo 11 spacecraft, became the first person to set foot on the moon. And then the last lunar mission, Apollo 17, was completed in 1972. So it has been a long time since we've kind of the mystery kind of went away there, I guess, of getting people to land on the moon. So it hasn't really, again, for the U.S. at least, again, I'm not sure about the rest of the world. In 1972, Apollo 17, again, there was some other Apollos in there, a nice Apollo movie where we had some kind of failed spacecraft, or failed missions as well. But again, that was kind of one of the biggest things going on at this time, was the race to the moon. Who was going to be the first one to get there? And there's actually even controversy over the quote of what was said when we first landed on the moon. But now kind of some of our more recent space missions. Scientists have gathered much new information about various planets and moons. A space probe is an unpiloted vehicle that can carry scientific instruments into space and then transmit that information back to Earth. That's kind of one of the biggest things we're going with now. Again, some of those great distances that we have to travel, those astronomical units, just aren't really possible for humans to do. So the Hubble Space Telescope, to kind of go along with those space probe, has also provided many views of our solar system and beyond. So those are just kind of some of our, again, not necessarily need humans, again, inside something, but we can still gather a lot of information that way. This is a space probe, again, called Cassini, that was exploring one of Saturn's largest moons, Titan. Again, this is just an illustration here, not an actual picture, but again, much easier to send a probe rather than sending a human those great distances to explore. Again, this is a moon, one of the largest moons, the largest moon of Saturn, known as Titan. Again, this is a space shuttle docked at the International Space Station. Again, computer-generated illustration here as well. Again, the International Space Station will be discussed more later as well. Recent human spaceflight has centered on the near-Earth missions of a space shuttle. Again, a space shuttle, what it is, it's a reusable space vehicle that's launched like a rocket, kind of attached to a rocket. Maybe you've seen those before, but then it can land like an airplane. And then the International Space Station is a laboratory, a permanent laboratory. Again, important here, International Space Station. Man, I feel weird saying that. International Space Station is a permanent laboratory designed for research in space. Astronauts from various countries are currently living aboard the partially completed structure, which is scheduled to be finished in 2010. So now we are in 2018, so maybe do a little research here. Is the International Space Station actually completed? And kind of maybe you could look up some of the things they can do on there, but the feeling we will discuss some of those in class as well. So that is it for section 1. Let me know if you have any questions.